All right, welcome everyone. Today, we're going to pull back the curtain on a piece of technology you use constantly, probably dozens of times a day, and you might not even know it's there. We're talking about APIs.
That's so true. I mean, from checking the forecast to logging into your favorite app with your Google account, APIs are the invisible messengers that make our digital world tick. And by the end of this, you're going to see them everywhere. So let's dive in.
Okay, so let's just start with a super common example. I pull out my phone, I tap the little weather icon, and boom, it tells me the exact temperature outside. How does it know that? My phone doesn't have a thermometer built in that can measure the weather for the whole city.
Exactly. It doesn't. Your phone has to ask for that information from somewhere else. It's the same thing with Uber seeing all the cars on a map, or when you log into a brand new website using your Facebook account. All these different apps are constantly talking to each other.
And the secret to how they talk? It's the API. Now that stands for Application Programming Interface.
Okay, that already sounds super technical and kind of intimidating.
It does, but I promise the concept is incredibly simple. Just think of an API as a really well-trained messenger. Its whole job is to carry requests from one piece of software to another and then bring back the response. That's it. It lets them cooperate.
A messenger. Okay, I think I get that, but can you break it down even more? Is there an easy way to picture this in my head? Oh, absolutely. The go-to explanation, and honestly the best one, is the restaurant analogy. It maps almost perfectly to how an API works in the real world. So picture this. You walk into a restaurant and sit down at a table. You are the customer. In the tech world, this is called the client. The client is just any application that needs some kind of information. Your weather app, a website, you name it. You know what you want, but you can't just go get it yourself.
Right? You can't just stroll into a restaurant's kitchen and start cooking your own meal. You need someone to bridge that gap. And that's the waiter. The waiter is the API. They take your very specific order, which we call a request, and they handle all the back and forth with the kitchen for you.
And the kitchen. That's the server. This is the big, powerful system in the background where all the information lives and all the real work gets done. The kitchen gets the order from the waiter, it prepares your food, which is the response, and then hands it back to the waiter to bring to your table.
That makes sense. And you can't just ask for anything, right? You have to know what the kitchen is actually capable of making. So is the menu kind of like the API's instruction manual?
You hit the nail on the head. The menu is the API documentation. It tells you exactly what you're allowed to ask for, the specific language to use when you ask, and what you should expect to get back. Without that menu, you'd just be guessing, and your order would probably get rejected.
Okay, I love that analogy. It's super clear. You're the customer, the waiter is the API, the kitchen is the server. Simple. But why is this so critical in the tech world? Why should we care so much about these digital waiters? Because, and this is no exaggeration, they are the invisible engine that powers the modern internet.
Think about it. When your phone checks the weather, it's using an API to talk to a huge weather database. When you log in with Google, an API is securely connecting those two services behind the scenes. Every time you see a Google map embedded in a company's website, that's an API at work. They let developers build incredible, feature-rich applications by just plugging into existing, powerful services instead of having to build everything from the ground up.
So if you're building an app and you want to use one of these APIs, you have to place your order in a very specific, very structured way. You can't just shout into the void and hope for the best. The kitchen, the server, needs to understand your request perfectly.
Right. It's like using the menu to make sure you're ordering correctly and being super precise about it.
Exactly. And pretty much every well-formed request has these 5 parts. You have the endpoint, which is like the specific address of the kitchen you're trying to reach. You have the method, which is the verb you're using, like get me this or create this. Headers are kind of like special instructions. No onions, please. Parameters are the details that narrow down your order, like asking for a large pizza. And sometimes you'll have a body, which contains the actual data you're sending over. Okay, you just mentioned the method is an action verb. What are the most common actions we're talking about here? Great question. There are a few, but you'll see these 4 all the time. Get is easily the most common. You're just asking to read or retrieve some information. Post is when you're sending new information to be created. And then put and delete are pretty self-explanatory. They're for updating or removing something that's already there.
This theory is great, but I'm the kind of person who learns by seeing. Can we walk through how all these pieces fit together in a real-world example?
For sure. That's the best way for it to click. Let's build 2 really common API requests, and we'll start with a simple GET request.
Okay, let's go right back to our trusty weather app.
The simple question we're asking is, what's the current weather in London? This is a perfect example of a GET request, because we just want to get some data. We're not trying to change anything on the weather server.
So, this is how that simple question gets translated into a formal language the API can understand. First, you've got the endpoint, which is that specific URL for weather data. Then, see that question mark? Everything after it are the parameters. We're saying Q equals London to specify the city, units equals metric to ask for Celsius, and then that APD is our special password to prove we're allowed to make the request.
The API, our waiter, takes that request, goes to the server, and the server sends back this chunk of data. It's usually in a format called JSON, which is just a simple way to organize information. I get it now. So my phone's app gets this raw data, and then it's the app's job to make it look pretty, right? It sees clouds and shows a little cloud icon, and it puts 15.37 in a big, easy-to-read font. You got it. The API just delivers the raw ingredients. The app is the chef that turns it into a beautiful, finished dish for you to see.
Okay, so that was getting or reading data. Now let's try writing data. Let's imagine we're signing up for a new service. We need to send our details to their server so it can create a new account for us. For that, we use a POST request. Now remember that fifth part of a request we mentioned, the body? We didn't need it to get the weather, but for a POST request, it's absolutely essential. The body is where we put the actual data we're sending. In this case, we're sending a name and a job title, all neatly formatted.
And if everything works, the server sends back a confirmation. See how the response includes a unique ID for our new user and a created at timestamp. That's the server's way of saying, message received, your new account has been created successfully.
So just to make sure I've got this straight, can you give me the super quick one-sentence difference between those two?
Absolutely. Here's the simplest way to think about it. Get is for reading data, like when you browse a web page. Post is for writing data, like when you submit a sign-up form. That's the core distinction.
This is really starting to make sense. Is this something that a total beginner could actually try out for themselves without having to, write a ton of complex code?
100%. There are fantastic tools out there that let you experiment with APIs directly. The most popular one is called Postman. It's basically a sandbox where you can build these requests piece by piece, send them off to real APIs, and see the raw data that comes back. It's an amazing way to learn.
Hey, before we wrap up, you mentioned that API key thing in the weather example. It just looked like a long, random string of text. What's that all about?
Good catch. Think of it like your password or your gym membership card. It's a unique code that proves to the API service that it's really you making the request. It helps them with security, it lets them track how much their service is being used, and it prevents people from abusing the system. Almost any public API you use will require one.
So let's just quickly recap the big ideas here. First, and most importantly, APIs are just those messengers letting different software programs communicate. Second, every request you make is carefully structured with those key parts, like the endpoint and method, so the server knows exactly what you want. And finally, you now know that these little digital messengers are the secret sauce behind so many of the apps you use every single day.
And that right there is why this is so cool to understand. It's not just some abstract technical detail. When you grasp the simple back and forth of a request and a response, you're fundamentally starting to see how the entire digital world is put together. You're really starting to think like a developer.